Hey guys, welcome to the NCEA Level 1 Geometric Reasoning paper from 2018. So how this video works is that I go through each question just to let you guys know what you need for achieve merit and excellence. Now for some of the questions, there are more than one way to do it, so I do apologize if I don't actually cover all of them. But yeah, so one of the suggestions is that you pause the video at the start of each question and have a go at the question just to see how far you can actually get with it. And then look at my answers just to see how you went. Okay, so let's get started. All right, so we've got our first question here, and what we have is AH and GJ are parallel. So that's basically these two lines are parallel, and then AG and HJ are horizontal. So that means we've got two sets of parallel lines there. And what we've been told is angle JGD equals to 51, and we've got to try and figure out what the answer or what the angle is for JHK. So that's going to be this angle here. So with this one, what we need to do first is we actually need to figure out let me just choose a different color pen. I'm actually going to figure out what that angle there is first. So that's going to be angle HAG. And angle HAG is equal to 51 degrees. And the reason is because you've got parallel lines, and of course they're going to be corresponding angles on two parallel lines. So we're going to put that as our reason. So corresponding angles, and we're going to put that as the two lines, which actually says that their parallel lines are equal. All right, now if you do want to actually write that in full sentence, I don't think that should be a problem. But this is just how the marking scheduler has actually written it. So yeah, just basically it's straightforward from that. So because we've got this angle here is 51, which means this angle here is also going to be 51. And the reason is because it is, corresponding lines again, because you've got two green lines that are parallel there. So in this case, we're going to get angle KHJ. Or X. You can just write it as X as well, but I think it's better to put it as what you want to actually make sure you put this part right here. All right, so that's KHJ. So once again, our two reasons are going to be the same. So corresponding angles in parallel lines are equal. And that's basically it for this question. So grades wise, one correct angle or one step shown gets you an achieved. Correct angle found with at least one valid reason. So you've got to actually get that reasoning correct to get a merit grade. Okay, so that's question 1A. Let's go to the next part of this question. All right, so question 2, guys, what we've got is write the angle Z in terms of Y. Now, I've already highlighted Z there. As for Y, that's this angle right here. And we've got to actually write it in with clear geometric reasoning. Now, there is, there's quite a few ways you can actually do this. You can actually do exterior angle, angles in a triangle, so on. So I'm actually going to do the exterior angle, because exterior angle of a triangle, so when I talk about exterior angle, this is exterior angle of the triangle, is the sum of the opposite of the internal angles. All right, so in this case, we can simply just say that Z is equal to 90 degrees plus Y. And then the reason would be that exterior angle of a triangle is equal to sum of opposite interior angles. Yeah, that's possibly the quickest way of how to actually do this particular question. And I think that one, correct angle found, simplified with at least one valid reason. Yeah, that gets you directly a merit. Now, as I said to you guys, there is another way of doing this. The other way of doing this is, I'm just going to get rid of these three red lines. So you're going to have to take like two steps. So for example, this angle right here that I've just colored in blue, that's going to be 180 degrees minus 90 degrees. Let me just do it like that, minus Y. Because remember, angles in a triangle add up to 180 degrees. So then this blue angle here could be written as 90 minus Y. So this is like the second way of doing it, right? So I can actually write down angle CBD equals 90 minus y, and that's because angles in a triangle add to 180 degrees. So that's my first reasoning. And then my second reasoning would be that z is equal to 180 minus 90 take away y, which is 180 take away 90 plus y, which equals to 90 plus y. And the reason that I'm going to give for that is angles in a straight line add up to angles in a straight line equals to 180 degrees. So this is the other way of doing this. So here you could expect to get maybe achieved here and then merit there. And as you can see, this method is just so much more quicker. Okay, let's go to the next question. All right, so what we have in this question is we've got a slide into a pool. Okay, so it's got a triangular frame, blah, blah, blah. Let's go to the bullet points there. The new council rules state that a slide must have an angle of less than 60 degrees. So I'm looking at the angle UTX, and that has to be less than 60 degrees. So that's this angle that's been highlighted in yellow at the moment with the water. And then a ladder of height less than 5 meters. So that's that one there. So the first step I'm going to be doing here is calculating that angle UTX first. So I'm going to separate this into a little triangle here, where this is going to be U, T, and X. TX is going to be 3 meters, UX is actually 2.5 meters. And I've got to try and figure out what that angle UTX is. It has to be less than 60 degrees. So looking at this triangle, what I have is, if I put this as, let's just say I'm just going to call this X as the angle. And this is going to be opposite. This is going to be A. So we're using a tangent function here. So this is going to be tan of X equals opposite divided by adjacent. So tan of X is equal to 2.5 divided by 3. And then X is equal to inverse tan of 2.5 over 3. So I'm going to get X is equal to. So let's just go figure it out. So we've got shift tan 2.5 over 3. All right, I'm actually getting an angle here of 0.69. Now, there's a particular reason I did this, because my calculator mode is actually in radians. Now, this is something you guys need to remember. In your exams, when you reset your calculator, it's going to go automatically into radians. You need to change it back to degrees. So to do that, just click on Shift, Setup, and then if you go down to Angle there, you see how it says radians? Just click on DEG, which it should change it to degrees. And if I press this again, you can see that the angle is actually 39.81. So that's the actual answer I'm looking for here. So 39.81. So this is less than 60 degrees. So therefore I can say something like this passes council regulation or council rules. Now I need to actually work out what the height is. All right, for the height, I'm going to create another triangle, which is going to be T, W, and Y. Now TY is 8 meters. WY is the height. So that's the blue thing that we're trying to figure out. We just worked out what that angle is, UTX, which happens to be 39.81 degrees. So I just need to work out what H is going to be. It's a terrible letter to be using, H, especially when you're using SOHCAHTOA, but let's call it something else. You want to call it something else? No, we'll just leave it. We'll call it YW, because that's the length of it. Okay, so let's label the sides. So I've got an angle here, so that means that's going to be opposite. And then we've got adjacent at the bottom there. So we're using tan rule again. So we're going to get tan of 39.81 is equal to opposite, which is, let's just go opposite over adjacent. So we got tan of 39.81 equals opposite, which is YW, divided by adjacent, which is 8. Cross multiplying it, we're going to get 8 times tan 39.81, and we're going to get YW is equal to, so I've already got 39.805 there, so I'm just going to use that. I'm just going to go 8 multiplied by tan of answer. That's a good thing about not getting rid of these things, and I can see that the height is going to be 6.67 meters. All right, and if you look at what the condition was, it had to be less than 5 meters. So if it's less than 5 meters, then we just kind of say this fails council rules. Okay, so I think what our question stated was find out whether or not the slide passes both of these council regulations. And we've kind of said that here. We've said that 1, it passes for the angle, but it doesn't pass for the height. So it's good just to kind of like write a little statement at the end. So we can say something like passes angle council rule, but fails height council rule, something like that, just to finish off the question. So looking at grades for this particular question, what you've got is for achieved, if you have the right angle, you can get an achieved equivalent maximum equivalent. Okay, so in this question, they do say that in the schedule, they actually say they accept 0.694 radians, because remember how when we did the angle there, it was 0.694 radians, so they are accepting it for achieved. For merit, you need both the angle and the height. All right, that's what's needed for both. And then clear working shown and overall conclusive statement. And excellence is this part here, writing those statements. All right, which was here and that one there when we wrote that how it passes the council rules. Now you can actually do this question using similar triangles as well. So if you're happy with similar triangles, you can definitely use that and come up with a statement from there. Okay, let's go to the next question. All right, guys, so what we have here is a classic bearings question. Actually, it might not be a classic one, but let's see. What we've got is O is the center, which is the sandpit, okay? And then let's actually look at each one of these bullet points, all right? So the first bullet point is this. The swing, seesaw, slide are all the same distance from the center of the sandpit. So if I was to draw a line like that, now all those 3 blue lines are going to be the same distance. Now, that's the first bullet point done. The second bullet point is the slide is on a bearing of 130 from the sandpit. So with this one, I'm going to choose a different color for north. So that's where my north is at the moment. Now it says the slide is on a bearing 130 from the sandpit. So if it's from the sandpit, then this angle here is going to be 130 degrees. Next is the seesaw is on a bearing of 285 from the sandpit. So that means I need a different color. Let's hope I can get a different. No, I'm just going to use these colors here. Sorry. Let's use green. So that's going to be 285 bearing. And then we are going to have a bearing of 350 from the sandpit for the swing. So that's going to be, yeah, maybe not blue is not the right color. Let's go with blue, green. Blue it is. No, I don't like blue. It's just too messy. Rainbow color. Rainbow color. Like that. So that rainbow there is 350 degrees. On the contrary, that's a really bad choice, but that's okay. All right, so once we have that, it now says that Madeline was standing at the seesaw. So we've got a Madeline who is standing at the seesaw. And she's actually facing the swing. This is the part where we need to be careful about. Because she's actually facing the swing, which is, that's not the swing. Where is the swing? Oh, she's actually facing the swing. So she's facing this way. And then we're trying to figure out what's the smallest angle she would turn to face the slide. So we're basically trying to figure out what that angle there is. That's what we're trying to figure out. Okay, so let's actually try and work it out. So let me just color that in there. Facing the slide. Yep, that's right. So what I'm going to do first is I'm going to put down O there, which is the center. And I'm going to create a new point called N, which is north. Which means G is somewhere there, and then we've got X, which is going to be somewhere there, and F, which is way down here. So just to clarify a few things here, the first thing is this. We've got angle NOF is going to be 130 degrees. So that's this part here. That's 130 degrees. We already got that sorted out. We also know that all of these distances are the same, which means this and this creates an isosceles triangle, and also this and this. Whoa. It creates another isosceles triangle. So we've actually got two isosceles triangles, and the angle that we're trying to figure out is both of those things there. So let's actually work it out. So we've got angle NOF is 130 degrees. The next thing is working out NOG, which is just highlighting it here, which is going to be that one, and that's going to be worth 10 degrees. All right, and the reason it's worth 10 is because we've got 360 degrees, take away 350 degrees, which gives us 10 degrees. Now the next angle I'm going to be looking at is NOX. NOX was the one that I did in green, so that's going to be 360, take away 285. So what do we got? 360, take away 285, 75 degrees. So this part here is worth 75 degrees. Which now means I can actually calculate angle GOX. So GOX is going to equal 75 take away 10, which is equal to 65 degrees. So that angle inside the triangle is 65 degrees. Once I figure out that 65 degrees, I can then work out what these two angles are, because they are angles in base angles of an isosceles triangle. So I can say angle XGO equals to angle OGX. So where I'm going to go 180, take away 65, divided by 2. $57.5 degrees. So those two angles there are 57.5 and 57.5. And I need to figure out, so remember this is what I'm looking for, the whole thing. So I need to actually work out two angles. So I also need to work out what this little angle here is going to be. But to do that, I actually need to know what this angle is, which is angle FOX. Now, the angle FOX is going to be, what do we have? That's 285 degrees minus 130 degrees, which equals to 155 degrees. Okay, because we can say that angle f of x is the same thing as saying, and the reasoning I'm going to put that is angle NOX minus angle NOF. So that gives us 155 degrees, which means we've got another base angles that are going to be the same for the isosceles triangle. So we can say that angle OXF is equal to angle OFX. So we're going to get 180, take away 155, divided by 2. 180, take away 155, divided by 2 gives us 12.5 degrees. And we're going to write the reason that it's angles base angles, I've actually forgot that as well, sorry guys. Base angles of isosceles triangle are equal, and I need to write that for this one as well, which is base angles isosceles triangle are equal. So once I get 12.5 degrees, then I can finally say turning angle is 57.5 plus 12.5, which equals to 70 degrees. Yeah, quite a nasty looking question, but you know, in fact, it's not too bad once you actually kind of get through it. So final answer gets you excellence, but you got to have the two reasons. And then if you have for a merit, you need 4 angles correct with 1 reasoning. And then for achieved, you need 2 relevant angles correct. All right, guys, that's it for this question. And let's go to the next one. All right. So question 2a, the first thing to realize is that this frame is actually symmetrical. If it's symmetrical at FE, that means we can kind of say that these 2 distances are equal. And if they're equal, then what they're going to have is we're going to have an isosceles triangle. And if we have an isosceles triangle, then this here is going to be 33 degrees. So that's the first thing I'm going to say. Angle LDA equals 33 degrees because of base angles in an isosceles triangle are equal. Once I do that, then I can actually work out what angle X is, which is DLA, which is going to be 180 degrees, take away 2 times 33 degrees, which gives me 114 degrees. And the reason for this is going to be angles in triangle add up to 180 degrees. Grades wise, this is a nice question for a merit. A correct angle or 1 step shown is achieved. Okay, the next part of the question, we're still with the same thing, but we want to calculate angle Y, which is here. Now what we can actually say is from the previous question, because we actually found out what angle LDA is, which is equal to 33 degrees. So that's 33 degrees. We can say, therefore, angle LDA equals angle BDA, because if you look at it, those triangles are in the same kind of area. And so once we do that, we can actually say that angle BDA equals to 33 degrees. And because angle BDA equals to 33 degrees, our next thing that we need to figure out is angle DBA, which is that one. So angle DBA is equal to 90 degrees because it's angles in a semicircle, or angle in a semicircle, sorry, equals 90 degrees. And then once we do that, we can actually work out what angle BAD is. Or the other way you could do it is you can actually say angle BDA plus angle BAD plus angle DBA equals 180 degrees. And the reason it's because it's angles in a triangle add to 180 degrees. And so we kind of just go fill up each one of them. So BDA is 33 degrees, BAD is 33 plus Y, and DBA is 90. So we're going to get 180 there. So what we end up getting is Y plus 66 is 153, no, 156 equals 180, and then Y is equal to 180, take away 156, and we're going to get Y is equal to 24 degrees. Okay, so grades wise, this question is also a merit question. And for achieved, you just need to get 1 angle correct and 1 step shown as well, or 1 step shown. All right, let's go to the next question. All right, so in this question, what we have is point O is the center of the circle. OC and BD are parallel. OC, which is that, and BD are also the same distance, because that's what it says here. Let's get rid of that. OC and BD are the same distance. Now it says prove that the length of the straight line AC, so that's this line here, equals the length of the straight line OD. So that's what we're trying to prove there, which is there. So the first thing to kind of realize is that we're going to actually create something, well, not create, we know that OA equals the radius of the circle. Okay, and because of that, OA, which is that, should be the same thing as OB, which is also the same thing as OD, and also the same thing as OC. And we know that OC equals to BD, which means we can actually say that's also the same thing, which equals to R. And because of that, we can now state that the triangle ODB is an equilateral triangle. Equilateral triangle. Our next thing is that we're going to say that AOC is equal to 60 degrees. And the reason is because OBD is 60 degrees, and then we've got corresponding lines. So we're going to write that up. So angle AOC equals 60 degrees because you've got corresponding angles in a parallel lines are equal. Okay, and if you want, you can actually put in there angle OBD equals to 60 as well, if you want to, because of that. Now, because angle AOC is 60 degrees, and we've got base angles of an isosceles triangle, this is also going to be 60 and 60. So we're going to write that down. Angle OAC equals angle OCA, and we're going to do 180 take away 60 over 2, which is equal to 60 degrees. And we're going to say that this is because base angles, isosceles triangle, are equal. So from here we can see that triangle AOC is equilateral. Now we already said that triangle OBD is equilateral. So that means I'm just going to fill these things up here, which is 60 and 60. Right, just having a look at the answer schedule, guys, and I'll be honest, like the answer schedule is almost a bit misleading because they are trying to actually prove that they're actually, in the answer schedule, they're trying to actually prove that this triangle is also an equilateral triangle. I'm not sure why they're trying to do that, because if OD, we've actually proven that OD equals to R, then all we really need to prove that is that this triangle is actually an equilateral triangle. Because if we prove that AOC is an equilateral triangle, then we can actually say that AC is equal to R. So I'm not sure why they're trying to do it the long-winded way. Because we proved that angle AOC is equilateral, triangle AOC is equilateral, I can say therefore AC is equal to R as triangle AOC is equilateral. And if that's done, if AC equals to R, we discovered that OD was the radius. And since OD is the radius, and I'll show you guys back there. So if you look at it, OD is the radius right here. So if that's the radius, which is R, since OD equals to R and AC equals to R, therefore OD equals AC. And I think that's what we were trying to prove. Yeah, I mean, like there's this extra steps that they're trying to do in the exam schedule. So I'm not sure why they're trying to do that. But anyway, grades wise, I think if you prove it finally, you end up getting an excellence. If you form two equilateral triangles, then you end up getting the merit part. So which is this and this. Achieved is like identifying one triangle as equilateral. Yeah, annoying little question, but anyway, let's go to the next one. Just when I thought annoying, here's another one. Alright guys, so what we're trying to look for in this question is we're trying to figure out what the length of FL is, because that's what the question is actually asking us. That's this distance right here. So to do this question, obviously that 0.6 there in the middle is going to be useful. So maybe we'll do it like this. So what if we create a line from O to L to try and figure out that? We already know this distance here is 0.6. So we need to actually work out what this yellow bit is. We know that this is going to be 2, and we can actually work out what the angle here is, because I can actually find out what the interior angles are in a pentagon. So that's what I'm going to do first. So I'm actually going to work out what angle FLK is. I'm just going to put that in a different color. So angle FLK is basically the pentagon that we have here, and I want to actually figure out what this whole angle here is going to be. So to do that, remember that we've got n-2 times the number of times 180 and then divided by 5. So what do we get? 180 times 3 equals that, divided by 5 equals that. So it's 108 degrees. All right, so that's just using, well, let me just put that as n. So we've got that extra step there, 5 minus 2 times 180 divided by 5, which is equal to 108 degrees. So that's what that red angle is. And then half of that, so angle, so we're going to put this as a reason is angles in a polygon. Now once we do that, we can actually work out what angle FLO is. So angle FLO is 54 degrees because it's going to be half of that. And I'm going to call this little yellow part of the that I want to work out. I'm going to call it, let's call it Y, just because it's yellow. Why do I use? Let's call that Y. All right, so what we have is we've got this triangle now that looks like this, where this is L, this is Y, this is 2. We figured out what this angle is, which is 54 degrees. And we actually want to figure out what that Y is. So hopefully you guys can see that this is the Y part, that's the blue part there, and the remaining purple part there. I'm just looking at that small triangle in there. So because it's going to be at right angles, which is there, our sides is we've got opposite and we've got hypotenuse. So opposite and hypotenuse, so we're going to use sine rule. And so we're going to say that sine 54 equals opposite over hypotenuse. Sine 54 equals opposite, which happens to be 2, and hypotenuse is y. So cross multiplying, I'm going to get y is equal to 2 over sine 54. And y is equal to 2 divided by sine 54, which is 2.47. Why is that not right? No, that's fine. So 2.472 meters. So that's the y part. Now I've got to look at this entire length of LO. So the length LO is going to be y plus 0.6. So LO is going to be y plus 0.6, which is 2.472 plus 0.6, which is 3.072 meters. So I hope you guys can see that. LO is the whole part, Y is just the yellow part, and the 0.6 is that little extra bit that's coming from there, from the center of that pentagon. So once we've got that, we're going to create another triangle now. And I have to use a different color, and I'm running out of highlighters. but let's just use this multicolored one right there. So this is going to go from here to here and across like this. I hope you guys can see that triangle. I'm running out of room as well. It's alright, let's just do this. So we've got, what's that distance? We don't care about from the center. We're trying to figure out half the purple part. So that's there. We know that this is LO, which is going to be 3.072 meters. We also know that this angle here is going to be 54 degrees. And we are trying to figure out what that purple part is, right? So then we've got adjacent and hypotenuse. So we're going to use cos rule. So we're going to get cos of 54 equals adjacent over hypotenuse. Cos of 54 equals the purple part. I think I called it, let's just call it A for now, divided by H, which is 3.072. So 3.072 times cos 54 equals adjacent, which is 1.806, I think. Well, let's just try it out. 3.072 multiplied by cos of 54 is 1.806. Now remember, that's only half of it. So we've only calculated this part right here. So we need to double it. And so our final answer is going to be 1.806 times 2, which is 3.61 meters. So grades wise, this gets you an excellence. Using the angle to calculate appropriate length relevant to triangle. Jeez. Okay, so this answer schedule is just like super messy because there's like so many things you could actually do to get a merit. Yeah, there's like a lot of little triangles there, right? I mean, like there's like multiple things that you can actually do to get a merit. For achieved, if you calculate the angle as 54, so that's somewhere there, you could get an achieved small right angle, big between 2, 5. Relevant angles, small. Yeah, guys, I'm sorry. It's just like this answer schedule is just like a bit messy to understand. But yeah, I'd say, you know, getting an achieved is getting one of these angles, and getting any one of these measurements should get you a merit. Yep, and if you want any further help, just have a look at the answer schedule online. All right, let's go to the next question. All right, question 1 here, folks. What we've been asked to do is calculate W, which is right there, and that's it. Cool, so we're just going to use opposite hypotenuse. So it's going to be sine rule. And we've got sine of W equals opposite over hypotenuse. Sine of W equals 1.8 over 2.3. And W is equal to inverse sine of 1.8 over 2.3. Shift sine of 1.8 divided by 2.3. And you got 51.5 degrees. Okay, I think this is the only achieved question that I saw in this paper. Everything else is like merit or excellence questions. All right, guys, just going back to that previous question, and I know I kind of rushed it there, but the reason I did that was because I actually created it into a right angle triangle like this. All right, so that's basically what I'm going to do in this case as well. So I'm going to create a right angle triangle like this because question 3. So for this question here, guys, what we've got to do is calculate the length of the rope. So the rope only goes from there to there. Now I do apologize if there was there's a bit of sound change because I just needed to change locations. Lunchtime at school, can't actually work anywhere. So I've got a right angle triangle and I've got to actually work out what the whole length is, and then I'm going to subtract 0.5 from it. So that's going to be 2.3, 1.8, and that whole distance is going to be AB. So I'm going to write down as AB squared equals, well, actually no, this is minus, isn't it? Yeah. So AB squared is equal to 2.3 squared minus 1.8 squared. And what I've got here is 2.3 squared minus 1.8 squared, and that's 2.05. And then AB is equal to square root of 2.05. So square root of answer is 1.43. So 1.43 is the whole distance. So that means the length of the rope now is going to be, I'm just going to write that here, length of rope is 1.43 minus 0.5, which is equal to 0.93 meters. Grades wise, this actually gets you a merit. Otherwise, finding the 1.43 gets you an achieved. All right, let's go to the next question. Okay, so with these types of questions, what I generally tend to do is like kind of just work out in my head steps of what angles I'd actually like to work out first. All right, and then I slowly start working, chipping away at it. So in this case, I want to actually try and figure out what angle Z is. All right, now looking at it, I've got the 50 degrees and the 22 there, which means the first angle that I want to work out is the step 1 is going to be there. All right, that angle. Step 2 is I could work out this angle here because they'll be vertically opposite. And then step 3 is working out this angle because that's base angles of an isosceles triangle. Step 4 is working out this angle here. That's step 4. Maybe I should put that in a different color. Hang on. So that's going to be step 4, which means step 5 is I could actually work out what this angle is because they'll be vertically opposite. And then step 6 is to actually work out what Z is. So as you can see, there's 6 steps in this particular question, and I'm literally going to run through each one of them. So step 1 was angle AOD. And angle AOD is equal to 180 degrees, take away 50, take away 22. So that's going to be 108 degrees. Now that's because angles in a triangle add up to 180 degrees. So that's my first one done. That's step 1. Step 2 is angle EOF equals 108 degrees because they are vertically opposite angles and they are equal. Which takes me to step 3. That's angle OEF. Now OEF is equal to 180 degrees. Take away 108 divided by 2. So that's going to be 72 divided by 2, which is 36 degrees. And that's because base angles in a triangle, base angles in an isosceles triangle are equal. Next, we go to step 4. But before we go to step 4, I just realized that step 4, we need to actually work out what angle OBD is. And I just realized that actually I do need this angle here. So that should have been like maybe my step 3.5. Sorry, I messed that up. 3.5. That's angle OBD equals 90 degrees because that's actually tangent to center of circle. So because that's 90 degrees, now I can actually work out what step 4 is. I'm running out of space, which is angle BOD. BOD is equal to 180 minus 90 minus 22, which actually gives me 68 degrees. And that's because angles in a triangle add up to 180 degrees. which then takes me to step 5. Step 5 was angle EOJ, which is this one here. So angle EOJ is equal to 68 degrees because their vertically opposite angles are equal. And finally, I can get to step 6, which is angle OJE, or angle Z in this case. And that's going to be 180 degrees. Take away 68 degrees. And what's step 3? Step 3's angle was 36 degrees. Which equals to 76 degrees. And then that's because angles in a triangle add up to 180. So yeah, so maybe not 6 steps, but a 7th step required. Answer completed with fully explained everything gets you an excellence. Merit is getting 2 answers correct with 2 reasons. Achieved is getting 1 answer correct with 1 reason. All right, let's go to the last question. Okay, so the way to look at this question is that you are trying to figure out what EC is. That's the distance, right? So this is what we're trying to figure out, which is kind of drawn up here. Now the problem is, this is kind of like the weird 3D image, but basically this angle here is 85 degrees, and then XB is there, which means XB is this distance here, which is this part. Which is the same thing as AX. So I'm hoping you guys can see that that yellow part is right here. Then we've got XE and XC. So XE is the green part, which is right there, and the purple part of XC is right there. Hopefully you guys can actually see that. So what I'm going to find out first is that blue line. All right, and to figure out the blue line, which is XB, so that's B and X, I'm actually going to use A, which is 85 degrees, and then that's 2.5 meters. So I'm just trying to break the question into like various ways of doing this. The blue part is what I need to figure out. So that's opposite and hypotenuse. So I'm actually using a sine rule for this. And so what I've got is sine of 85 degrees equals opposite over hypotenuse. Sine of 85 equals opposite, which is XB, and the height is 2.5 meters. So cross multiplying, I got 2.5 times sine of 85 equals XB, and now I just need to work it out. So I've got 2.5 times sine of 85 equals 2.49 meters. So that's what XB is. So this part right there is 2.49 meters. Now the next part is actually looking at this right angle triangle here, which is BXE. All right? Because if you look at BXE, so that's BXE, and XE is the green part. BX we found out to be 2.49 meters. We also know BE is 3 meters, so we can actually figure out what XE is. So in this case, XE squared equals 3 squared minus 2.49 meters squared. So then XE is equal to square root of whatever that is, which is 3 squared minus 2.49 squared, which gives us 2.799, and then XE equals to that, which is 1.67 meters. So what we've discovered is this distance is 1.67 meters, and same with this. So once we've figured out that part, we can kind of see that because this angle here is going to be 120 degrees, we can cut it into half and make this 60 degrees. So by doing that, what we've effectively done is, so that's going to be X, that's going to be C, and well, whatever that point is, it doesn't matter. It's going to be 90 degrees. That's 60 degrees. This is 1.67 meters. So that's the purple line right there. And then this is half of the blue line. And we basically want to find out what half of that blue line is. So that's going to be half of D. All right. The reason I put it half of D is then we can actually just do it in one go. So using, what is this going to be? Hypotenuse, opposite. We end up with the sine rule again. So then we've got sine of 60 equals opposite over hypotenuse. Sine of 60 equals opposite, which is half D, over hypotenuse, which is 1.67. Then 1.67 sine 60 equals half of D. Of course, you could actually just find D by itself and then double it as well, which will still be the same answer. But I'm just going to go 2 times 1.67 times sine 60, which is 2 times 1.67 times sine of 60, and that gives me 2.89 meters. Alright guys, so grades wise, final answer with the grade gets you excellence. CE. Final answer stated with working. It's weird because it says 2.9 meters is the final answer, but then you also get merit for that. Oh, okay, right. So if you find 2 correct heights or lengths, you actually get a merit. So 1.67, so you probably need that and that. 1.45, where's that? Oh, 1.45 is the other one. Okay, yep. So you could have potentially found this one here as well to get a second thing as merit. For achieved, you just needed to find one of the distances. Cool. So achieved, yeah, achieved is basically finding this or this or this. You know, I think if you're getting up to this point here, you're probably going to get a merit anyway. Alright guys, that's basically it for this question. Alright guys, so that's basically it for this little explanation video. Now with your questions, when you attempt the exams, just make sure you attempt all questions, just write all answers. Even if you don't remember the reasons, just write the answers. Alright, as always, don't forget to like and share this video and subscribe to keep up with the latest content. Just know when the tutorials are on. There should be some revision material popping up, hopefully. But apart from that, thank you for watching and good luck.